All right, so we're live with another Enterprise MLOps interview. And today we have Malcolm, who is a graduate of the Duke MIDS program, one of the elite data science programs in the world, and also in a MLOps expert as well. A lot of the work he did on his capstone was covering MLOps material. So let me let Malcolm introduce himself and maybe tell people what you do and a little bit about yourself.
Yeah, so thanks for having me, Noah. Yeah, as Noah mentioned, I am a recent graduate from the MIDS program at Duke. Um, kind of about to kind of jump into a role at DoorDash, doing some machine learning there. I was looking forward to that. Again, yeah, as Noah mentioned, my capstone project really was heavily MLOps related, um, and I was thankful to kind of be able to pull from a lot of the expertise that I was able to learn from him during my few classes there to really kind of be able to leverage the cloud and various MLOps, just like mindsets and thinking for Bria to kind of make this project as effective as it actually was.
And the project you worked on, you want to just explain like the problem the company was trying to solve, and then what machine learning technique they use, and then your architecture, maybe like high level.
Yeah. So we were working with a conservation organization that kind of looks to kind of identify. They were trying to identify animals in um, camera trap videos that they have. Uh, we were kind of working on part two of this project. There's their capstone the year before us had been working with images, so we were kind of the scope of the project had already been defined. So we were kind of working with again trying to identify animals in these camera trap videos, and having to work with object detection modeling, which we'll get into, kind of exacerbates a lot of the challenges that you'll face within MLOps, kind of that whole life cycle. Um, but I mean, on the at the very end, kind of our infrastructure. Um, I mean, I guess I could show kind of a little diagram of what the infrastructure
Yeah,
was at the end. Let me pull up.
we can even add it. I can even do now. You can
Yeah, no, this is perfect. Yeah, just like that. I guess at the end, kind of the infrastructure that we had set up really was like a website that the kind of users could go to and like upload a video, um, and essentially using AWS and kind of be able to use batch to kind of be able to process a lot of these videos simultaneously. We kind of had this object detection backend that kind of did some processing, and then that was kind of shipped off into a DynamoDB database, which then was exported into a Dropbox for the user to be able to use. Um, I mean, I think one of the big things about working on this project and kind of working on an MLOps related kind of project outside the scope of a kind of big company is that I think oftentimes we look at MLOps as something that is really focused on like the last stage of the machine learning life cycle of this kind of the implementation and maintenance section of it. But realizing that for anything to really to be operationalized, you really have to have everything from the initial data engineering stuff, that data ingestion and data acquisition side of things, through the modeling, through kind of be able to validate everything, and then the implementation and maintenance, and kind of working through all of those different stages and trying to build that out, and get that really operational in a way that, okay, if I need to retrain the model, am I actually able to have the infrastructure there to be able to take any new data and get that prepared? Can be quite a challenge, especially when you're not working with data that fits into a Jupyter notebook, like having 6,000 videos.
Yeah, that's an interesting point you bring up, actually, because one of the things that's interesting about MLOps is that the reason I think so many people are interested in it is that I was looking at some data recently from Google because I took the Google Professional Machine Learning exam, was able to pass it, and one of the things that they brought up in when I was studying for that was that something like 70% of companies that have done AI have not even released a project, or I think it's like 50 to 70% of companies doing ML have no ML. And so, if imagine any other thing that a company did, if the failure rate was that high, there would be a real problem. Like, it would be like if a car company, 70 to 90% of them didn't make cars, right? Like, wait, whoa, what's happening? And the thing you brought up, I think, is the point is that a lot of the way I think people way people have been thinking about it was that, oh, at the very end, let's just do MLOps. But what you said, I think, is actually the key, which is that at the very beginning, you have to think about it from a production first mindset.
Yeah, yeah. And that was like, I mean, that was one of the biggest challenges with this project. Really wasn't even the deployment side of stuff and or like the modeling. I mean, that stuff took a while to kind of build out, but it was really kind of for this project was that really initial data preparation section of it and being able to get the data preparation infrastructure built out in a way that, like, if we had but again, we have 6,000 videos. You can't, if you want to do, like, how am I going to split out these videos based on the class? So it's like, okay, if I have like all these different animal classes, okay, I need to have a certain number of videos to allow myself to even train with it. Okay, so how do I even know which video animal classes am I going to even use to train? Now, how do I do a train test split that's going to split stuff appropriately when I can't just import train test split anymore because it's not in like a tabular format of data. And so kind of, I can kind of show some of the stuff that I was working on kind of was that even just kind of just getting started on this stuff, I was thinking about it in terms of, okay, if I need to go back and retrain the model, which is kind of a big part of operationalizing machine learning, can I kind of reformat all the data? If we get new data, can we reformat all the data and get that all prepared for modeling? And so the biggest thing for us, the first stage for us, was really trying to get the data into a format that you could kind of validate and look at the data from like the outside and understand what's going on, kind of getting it into a tabular format, like something like this, where I can see, okay, I can see the animal class, I can sort down, was the video even annotated from this big data set of videos? When you are training an object detection model, you have to look at stuff as like a frame by frame basis. And so I'm like, okay, well, I need to know what frames are and aren't annotated. So kind of being able to take your data and format it in a way where you can at least really quickly go and just look and see, okay, this looks right. Then I can move to the next stage. And so once you do have everything kind of automated and working, if something does break, you're able to go back and see where it is that something may have broken. But even getting something to a stage like this involved a lot of infrastructure, kind of going through, taking the raw data, using, again, the power of the cloud and doing all of this stuff is kind of unrivaled. But kind of being able to take the raw data, import this into a database, then being able to take that, do the train test splits on the data that's now in the database based on some criteria that I had set up. And then other functions that were there to then have all these annotation labels that need to get prepared for training, and kind of creating Lambda functions and some infrastructure behind doing that, and then creating Lambda functions for splitting the videos up into individual frames and putting those into the appropriate folders that then when I'm training, I can kind of pull from. And I think this is a part of, again, MLOps that people probably don't realize needs to be operationalized. It is like a massive time suck, which is, again, this is likely probably why people try and do AI machine learning stuff and then realize that, okay, like we have our model now, let's get this operationalized and get it deployed. It's like, okay, now we need to retrain the model. And then they're like looking back and it's just like a mess of everything they have to go through now of trying to like, oh, like what, how did we split this data originally when we were training this? How did we format everything? How did we get everything prepared for being able to train?
Yeah, it's one thing to create a model once that does something, and then it's another thing to actually have the model use the production data that's changing all the time.
Yeah, and I don't blame kind of the confusion in there a lot of times. I mean, I personally, I think ML ops is looked at as like the ML engineer does ML ops, and then the data scientist does like the model training, and then the data engineer does the stuff before they're preparing the data. But kind of actual ML ops involves the work of all three of those people. And so if you're not at an organization that has a data engineer, a data scientist, an ML engineer to kind of compartmentalize those different jobs in there, then you can kind of get looked at as you're going to have to do it all. And I think that that's kind of an overlooked area.
Yeah, I think one of the things that could be happening too is that we're going into maybe a recession. I forgot if we're in it or not, or it's equivalent of a recession essentially. That as when companies are looking for ways to trim their staff or whatever, I think they're going to be looking for like specialists that need other people so that they can produce results. That's been my experience in the tech industry. If you're a specialist that can't get anything done unless you have a whole handful of other people supporting you, then you're not as valuable as someone who can get the whole thing done, right, end to end. And I think that the MLOps area is only going to grow in importance, and that many organizations will be hiring into specifically MLOps. And if you're a data science, if you have data science skills, I think that's great. But I think it's even more important to have MLOps skills uh, because of the fact that from a hiring perspective, really that's what I think organizations are looking for.
Yeah, I mean, yeah, I mean, I'm curious how that actually is going to go, because I mean, I don't, I if I was doing all of this as a full time, kind of this whole end to end from everything, I mean, they better be paying me the big bucks, because I mean, it's a lot of work and a lot of different things that you have to be able to think about. And I think the expectation that someone you can find a lot of people that can go through and actually know the skills to be able to do each and every step and do them well. Um, like I don't think that that's
Yeah, and I think what happens in an emerging field like this is that there are people that do what you did and do the end-to-end solution, and then ultimately the platform technology starts to make it a little more straightforward. And so what we're seeing now is that there's technology that really does standardize things. And so you can do MLOps from the very beginning if you're using like the correct platform. So if at the very beginning you're versioning your data, if at the very beginning you're versioning your models, if at the very beginning you create a feature store where all of the calculations and transformations go into a feature store, and then everybody in your company is standardizing on like some specific tool like SageMaker, Databricks, Snowflake, Aguazio, there's a whole bunch of different email platforms. Then it actually becomes more straightforward. At the very beginning, I think there was a lot of questions about what was important and what isn't important. And like, we're seeing now, for example, this concept of I mean, things are moving very quickly. Experimentation tracking. I think someone asked about that. Like that's now becoming a pretty standard tool for many MLOps platforms, where every time you train the model, there's a lineage where it says, here's the accuracy of the model, here's the algorithm I use, here's the notebook I use, and here's the data I use. And then you can actually go back and compare runs, or even if you had a data governance issue, for example, like there was some kind of PII or person identifiable information, and then you got sued, or you have bias in your model, and you had to go back and like recreate it. That's what the experiment tracking system can do. So I think that's probably what'll happen, is that there's going to be a lot of hiring into ML ops and ML engineering, and at the same time there's going to be more and more standardization on platforms. And I think as well, the certifications will probably continue to become a big deal. Like the one I took for Google, I think is a pretty good one for MLOps. I think it may be the only MLOps certification. I mean, I took the AWS ML certification, and that has some MLOps, but I think the Google one is really heavy into MLOps. And so I think those are the combination of platforms, certifications, and then people who are willing to do MLOps. And then they can probably become leaders in an organization very, very quickly
Mhm.
because there's so few people that know MLOps.
Yeah, no, definitely. I guess, yeah, because definitely when you start looking at stuff on the platform side of things, then yeah, I mean, I think that was I had when I initially started working on this project, I really wasn't familiar with Databricks and all that stuff there, and like that probably would have been an area that if I had kind of started from everything using Databricks, I probably could have streamlined some of these processes that I was going through, and not had to build everything from scratch. But I think one of the things that I was happy to kind of build everything from scratch during my capstone is that it forces you to really identify all the areas within the machine learning life cycle that you kind of need to be able to like operationalize, but then also still have like the correct checks in place to be able to go back and validate what you're doing, and not just kind of skipping over stuff that, I mean, again, a lot of the platforms kind of do it for you, but I'm somewhere where it's like, okay, I know the platform is doing it for me, but I still need to know what I still want to know what exactly it's doing and like why it is that it has the extra checks in there.
Yeah,
Uh,
I agree. I think what you built, each of these components are really good skills for software architecture, like for understanding how to use object storage, understanding how to use something like SQS, which can handle infinite IO. I think a lot of times people don't really um, understand like how powerful a system like SQS is. Like it can handle an infinite amount of requests.
yeah, yeah. I mean, actually, so we can kind of dig into we got kind of theoretical in there, but we can kind of dig into really some of the stuff that I kind of built out for this project as well, and really kind of how, um, like the infinite scalability of SQS and kind of Lambda really kind of and batch kind of enabled us to be able to build what we did. Um, I mean, just kind of for something along the earlier sides of being able to kind of prepare the data for training, we needed to have the videos on a frame like frame by frame, like to be able to pass through the model of the train. And so you say you have 6,000 videos, and then each video can have up to 900 frames, like 30 FPS, 30-second video. Um, it's like if I have to go through and like individually split all these videos up and go through and then split them up and then do like a train test split with all of those videos. If I had to do that just like without any type of concurrency, it would have taken like a week to run it on my laptop. But just kind of being able to kind of throw everything, all the video names into SQS, and then have those kind of go through, and then trigger a batch function, or trigger a back function or a lambda function that kind of can do some processing for me, that then save stuff away. It could be done in 5 minutes. But literally, like what I see on my computer, I would go through and like look at the estimated time to finish up thing, and it's like, oh, this is literally 3 days of runtime being able to accomplish in 5-10 minutes, which is like pretty miraculous in some way. I will say that for folks that aren't familiar with like that are familiar with Lambda but haven't really touched AWS Batch, uh, essentially, don't be afraid. They're very similar tools. It's just Lambda has a runtime limit and Batch doesn't. So that's honestly the reason why I used the Batch heavily in this project, is because when I were trying to process 900 frames, it would time out a Lambda function runtime. Um,
and with batch now, I believe that they support, does it support ECR now? Is that correct?
yes, yeah. So it's ECR. You can run Batch on Fargate instances,
Mhm.
and so it's really. I mean, once you get stuff set up, it's really easy. I think I have some of the Batch stuff here. Really, yeah. You just create a job queue that you'll set up. We have a job definition in a compute environment, which I can use like Fargate spot instances which make it really easy that I can just point stuff to a container in ECR that I write that I know can do what I want to do well, and it will spin up however many environments needed for it. I don't have it on within this account. I got locked out of the MIDS account, but
So you were using then what's nice, I guess, about using spot instances with Fargate is that you can still run a container, but you can get, 80, 90% off savings, right? So you
yeah,
can get monster machines.
yeah, yeah. And so yeah, you can run it there because I mean Fargate's a little bit more expensive because they are really designed for containers. But when you're working when I'm kind of doing stuff on my own with a small team, working with an organization that is relatively small and doesn't have a ton of money, it doesn't have the technical expertise to kind of be able to go back and like look at what maybe went wrong in something when they're actually using it. Keeping it simple and letting AWS do most of the work, but also trying to keep the cost down is definitely the best way to do it. But one of the really interesting things about it was a fun thing to see using stuff with batch and again really understanding like the power of that concurrency this allows for is that when I was doing I would have a training job that would do that was like data preparation within batch, and I would kind of hit go, and then I would go jump over into batch, and I would look at literally like 900 chain split jobs or like jobs start kickoff at one time and just be running. And it was like, wow, like this is actually like you could actually visualize how powerful it is when you're like, yeah, it's taking like 5 minutes for each job to even finish, and there's like 900 of them running. Like you can calculate how many hours of time that saves.
Yeah, it would have taken you days and maybe a week or 2 weeks to like write a Python script that splits all the frames into or the videos into individual frames, and by using SQS plus batch, you have what they call an embarrassingly parallel problem, which is it's perfectly suited to parallelize.
Yeah, definitely. I mean, and there are parts of it where it's like, okay, um, like there are parts of it that made some issues that had some issues. Actually, like, so it's also the way you have to think about the problem too, in terms of like, okay, how is it actually parallelizable, and like break stuff up into stages that make it so you can run stuff in parallel. Um, like which is again like I don't like the fact that like I'm still impressed that I was kind of able to get all this stuff done, but for it to be able to kind of get the data into a format that was kind of in a table that you could kind of easily now go through and run everything with, like had to create a function that one would go through and like put some basic information about these videos into the table, which kind of had to go through and do that, and then create these data set splits based off of that, so that the video the functions that I was writing in parallel, it could only look at videos that were trained, and so it wouldn't just break everything. Because you either have to be a master coder and understand and have all these exceptions and cases in there that can handle every different variation, maybe bits of bad data, bits of good data in there when you're running stuff in parallel, because not everything is the same when you're trying to prepare stuff. But kind of being able to chunk things out and look at stuff as individual problems that like, okay, this small problem here of just get the raw data, just metadata from it into a database. Okay, I can parallelize that easy. Okay, let's kind of add a class label to the videos that are, or just add a marker if it's okay. Is it an annotated video or is it a non-annotated video? Okay, I can parallelize that process. Cool. And then okay, let me go through and now add a data set split to that. If you can break out stuff into those smaller stages, then yeah, you can parallelize a lot of it. If you look at it as a bigger thing of like, okay, I have all these videos and I want to get it to the very end, then you're going to have a lot of issues in trying to actually parallelize it. And so
Yeah,
kind of
you're raising a good point, which is that's one of the essential skills of software engineering is to take complex problems and break them into simple problems. And because you had such a powerful tool with AWS, that's literally the superpower, right? Is it's waiting for you to break big problems into little problems.
Mm-hmm. Mm-hmm. And again, it's like they're like AWS has it has all the superpowers there. I mean, and all the tools there to be able to do it. The cloud, the ability to do, has the ability to do pretty much those things you want to do, but just to be able to actually think about it at a small enough scale and not just look at it like, oh, okay, like I can do it all in one step or in two steps, but really kind of just.
And somebody's asking, did you use FFmpeg to split things up, or what was your tool that you used to split out the frames?
I used, I think I just used um, like OpenCV,
Okay.
and that was So I'd go through and just go through and save the frame, each individual frame. So essentially, it was going through and it would. I don't know if you've ever done anything with OpenCV and you're trying to like watch a video, it automatically look at stuff into an individual frame, and then it was just I just had it save each frame of the
So
videos
it
into a
basically
frame.
it implicitly kind of makes the problem easy. You just
Yeah,
yeah.
you just have to you have to tell it to save. One of the interesting things about when you're working with OpenCV and you're in there, like you can have it skip frames, stuff like that. Some of the numbers that you kind of put in once you actually realize what it's doing, you're like, oh, it is looking at this frame by frame level, um, which is again some of the things that one of the challenges of working with kind of again in an environment and doing kind of MLOps for a company for an organization that doesn't have infinite resources in a sense where it's like okay, like I couldn't train on all the available frames that I did have, so it was okay, how can we go through and effectively without losing power in like their predictive capabilities train on a small segment of the videos there. And so being able to kind of go through, kind of split out some of the data, realize that okay, I can't train on everything. Now I have to split our data, but now I'm kind of tweaking. I'm taking every other frame or every third frame of the video because the ones right next to it are going to be really similar. And so being able to kind of build out a process that allows you to be able to go back in and just make a couple tweaks there to be able to say, oh, I can't need to do every third frame. Cool. Let me just make that part easier rather than having to, okay, I have to start all over again and rebuild out a whole new processing framework.
And that's a very good point you bring up. And did you find yourself using continuous integration much as well? And did that help you?
I actually did not find myself using it that much because a lot of the challenges in there weren't as much along the lines of um, like the like having stuff when it was already deployed. It was kind of that it really wasn't much an issue with getting stuff kind of pushed up and getting that change deployed. It was really more along the lines of like, okay, how do I just get this one part working, one piece working? And then once I was able to get that working and pushed up, it was fine.
So
Working within,
like a data operations.
yeah, I kind of had my own system working within the MIDS AWS account as well, and with they had us working on GitLab, which does not have the best infrastructure for continuous integration. That's kind of immediately there, and then like it was Duke OIT was managing the GitLab, so then like there were certain things where they didn't have the Duke accounts didn't have permission to some of the continuous integration stuff, and um,
yeah, this is a kind of a classic problem with what I've found this in my career too, is that a lot of times if you're obviously an innovator, when you're innovating, you have to actually kind of jump around IT. so and there's reasons that IT has the security and they're important, but a lot of times in an organization you're going to have to be creative because sometimes the amount of effort to get IT to change something isn't worth the reward. And so you just have to figure out like a hack or like a shadow infrastructure to get what you need done.
Yeah, you just gotta figure it out, and make it work. Um,
That's cool.
yeah, I mean, yeah.
So any maybe last thoughts, or like what ways that people can get in touch with you or talk to you about MLOps?
Yeah, I mean, if you folks want to get in touch with me, just shoot me a message on LinkedIn. Happy to chat. Yeah.
Awesome. Well, as I mentioned, when you graduated, I definitely would buy stock in your company. I think you're going to do very well.
Thank you. Thank you. Appreciate it.
Okay. All right. Well, thank you again, Malcolm, and I'm sure we'll talk again soon.
Definitely. You have a good
Okay.
one.
All right. Bye.